Hi everybody, now that we know the basic operations, I want to talk about some more complicated problems with fractions. So things like what we call complex fractions, and also just doing a little bit of examples with the order of operations and fractions as well, because all those rules still apply here too. So in this video, we're going to cover complex fractions and the order of operations with fractions. So I'm going to start with complex fractions here. So a complex fraction is a fraction, let's just say whose numerator or denominator or both also contain a fraction. So you basically have a fraction in a fraction. So for example, something like 1/2 over 3/4. Right? Really messy. That's why they're called complex, because they are complex. Or something like maybe 5/6 over 3. So here you have a fraction in the numerator. Or maybe something like -4 over 1/2. Okay, so you have a fraction and a fraction. It could be in one spot, or it could be in two spots, but we have fractions and fractions. We don't like to leave our answers like this. This is really messy and really complex. It's very complicated looking. So what we need to do is we need to clear these out. And we can also get more involved here too. So we can actually even bring in operations. So you could have an example like 1/2 plus 3/4 over 5/6 minus 2/3. Right now we're getting really, really complicated here as well. Or maybe something like 4 minus 1/2 over -3. So again, really, really messy stuff. And how do we clean it up? Okay. So there's two strategies for how you can simplify these. The first is to use division to simplify. Okay, so remember that if you have A over B divided by C over D, then what we do is we change to multiplication and we flip that second fraction, right? So for example, let's say I have something like simplify 1 over 2 over 3 over 4. Now, this big line here is a fraction bar, which just means division. So even though this looks really messy, I can actually rewrite this. This is the same thing as having 1/2 divided by 3/4. And then now you can see that's actually something that we've already learned. So I can apply my regular division techniques here, right? I'm going to flip that second fraction. And then I can go ahead and multiply straight across. So I have 4 over 6, and then I can simplify to get 2/3 as my final result. All right, let's do another one. So maybe I have x over 3 divided by 4 over 6. So first thing I'm going to do is rewrite x over 3 divided by 4 over 6. And then I'm going to go ahead and apply my regular rules. So I'm going to change to multiplication. I'm going to flip that second fraction. Now here I do notice that I can simplify before I multiply, because I can divide these both by 3. So I have x times 2, 1 times 4. Now, usually we write it the other way. So I'll write this as 2x, and then 1 times 4 is 4. Do be careful, though, because I do see that I can divide this again by 2. So I have 1x over 2, and 1 times x is just x. So the easiest thing to do there is to just rewrite them. And I'm going to do one more example that's a little bit harder, but for our purposes, this is kind of, really where you want to focus right now. So this is more like a challenge problem. So maybe we have something like 1/2 plus 1/8 over 3/4 minus 1/6. So when this happens and you have something more complicated, then what you want to do is simplify the numerator and denominator first. Okay, so I'm going to take that numerator. So here's n for numerator. 1/2 plus 1/8. So the first thing I need to do is I need to change these and find my LCD and make them like terms. So I'm going to notice here that my LCD is going to be 8. And again, you can try that at home if you need to. If I find my multiples list, I see I'm going to hit 8 first. So I'm going to go ahead and change this over. So I have 1/2 needs to go to 8. And the 1/8 is already all set. So I just need to convert this 1/2 over. And I'm going to multiply that by 4. So my problem becomes 4/8 plus 1/8, which is 5/8. And then for my denominator, I'm doing 3/4 minus 1/6. And again, you can try this out at home, but your LCD is going to be 12 here. So in the first case, I'm going to be multiplying by 3. 4 times 3 is 12, so I get 9. And then the second case, I'm multiplying by 2. And 1 times 2 is 2. So my problem becomes 9/12 minus 2/12, and which is 7/12. So my numerator is going to be 5/8. My denominator is 7/12, and now I have a problem that I'm used to working with. So now I can rewrite it, change it to multiplication, and flip that second fraction. I do see that I can simplify a bit here, so I'm going to go ahead and divide those each by 4. And I get 5 times 3 and 2 times 7, so I have 15 over 14. If I check, I do see that this is actually simplified. So I know I have that final result there. And I can leave this as an improper fraction, or I can change it to a mixed number, but it is simplified, so I'm going to stop here. So that's our first strategy. This has to be my preferred method, is to just kind of use what I already know. So if I have something more complicated, I can simplify the numerator and denominator first. But basically, we just rewrite that as a regular division problem. Now, the second method is to multiply everything by a common denominator. And what that does is it allows us to cancel out the fractions. So let me do the same examples here. So I have 1/2 over 3/4. So I do need to find my LCD here. So you're still going to start the same way. I shouldn't say that. You're not starting the same way, I guess, in this case, right? Because in the last example, if we're multiplying or dividing, we don't need these common denominators. But this one reminds me similar to like the example we just did. So I do need my LCD here. So I'm looking at 1/2 and 3/4. So I have my two denominators, which are 2 and 4. So my LCD is going to also be 4 here. And then what you do is you multiply the numerator and denominator by the LCD. So my LCD is 4 here, so I'm going to multiply by 4 over 4. The reason I can do this is because 4 over 4 is just 1, so it doesn't actually change the value. But what's going to happen when I go to simplify now, I'm going to rewrite this. So I have 1/2 times 4, and then I have 3/4 times 4. And what I can do is put that 4 over 1. And what's going to happen is I'm going to just simplify each piece now. Simplify my numerator, simplify my denominator. So in the top here, I get 4 times 1 is 4. 2 times 1 is 2. And 4 divided by 2 is just 2. And the denominator, I get 3 times 4 is 12. 4 times 1 is 4. And 12 divided by 4 is 3. So what ends up happening is you're going to end up canceling the fractions in both the numerator and denominator naturally, and you're just left with the final result that way. So this strategy also works. Let me do one more here. Just like we did the last one. I'm doing the same exact examples just so you can kind of see. So we had x over 3, and then I had 4 over 6. So this time, instead of rewriting, we're going to find the LCD. So my two denominators here are 3 and 6. So my LCD is going to be 6. And again, if you need to pause the video and try that out on your own, please go ahead and do that. And you're going to multiply by 6 over 6. So this becomes x over 3 times 6, and then 4 over 6 times 6. And don't forget, you can put those whole numbers over 1. So here, what I'm getting is 6x over 3, and then I'm getting 24 over 6. Now you want to keep simplifying. So if we just figure out this x for a second, 6 divided by 3 is 2. So my numerator becomes 2x, and then 24 divided by 6 is 4. Now just be careful. I do have a little simplifying I can still do here. So I can divide these each by 2, and I have 1x over 2, or just x over 2. So we get the same answer as we did before, just again, a different strategy here. All right, and I want to show you that challenge problem too. Okay, so again, this is a bit of a challenge problem. And we're using that second strategy. So I do need to find the LCD. Now here, you want to be careful. Your denominators are 2, 8, 4, and 6. You do each of the denominators in a challenge problem like this. And if you do your LCD out, you should find that the common denominator here ends up being 24. So you can do your multiples out, or you can use your prime factorization. And again, you should get 24. So what you're going to do is you're going to multiply by 24 on the top and the bottom. So I have 1/2 plus 1/8 times 24. And then I have 3/4 minus 1/6 times 24. And these are actually in parentheses because they're the whole thing together. So this is really a challenge problem here. And what you end up doing is you use the distributive property in either case. So you're going to have 1/2 times 24 over 1 plus 1/8 times 24 over 1. And then the bottom, you'll have 3/4 times 24 over 1, and then 1/6 times 24 over 1. Again, this is a challenge problem, okay? So this one's tough, but we can do it. Now we multiply straight across here. So I'm going to get 1 times 24, 2 times 1. Here, 24 over 8. I'm just kind of going a little bit by little bit. Let me simplify here. 24 divided by 2 is 12. 24 divided by 8 is 3. So I end up with 15 in my numerator. Now for the denominator, I am going to do a little bit of simplifying here. So I am going to divide this by 4 to start. Those numbers are getting kind of big. So I have 3 times 6, which is 18 over 1. And then here, same thing. Actually, this one's not too bad. 1 times 24 is 24, and 6 times 1 is 6. So I get 18 minus 24 divided by 6 is 4, which is 14. So we do get that same answer, just a different strategy here. And again, you're welcome to use either strategy. I tend to like the first strategy. Sometimes it's a little bit longer, but I like it because it uses everything we already know. Whereas this idea here, it still works. It's just a little bit more complicated because sometimes we're distributing and we have to remember all of the multiplication rules as well. But they both work and they both allow us to deal with these very, very complicated examples. And they really are complicated problems. Okay. All right, so the other part here of this video is just going to be a review of the order of operations again. So you can still go ahead and use those order of operations here. So remember, your first thing is going to be to do all grouping symbols, so parentheses, brackets, etc. The second thing you're going to do will be your exponents. And then we multiply and we divide from left to right. And we add and we subtract also from left to right. So all the stuff we've already learned, again, can still be applied. So I'm just going to do maybe like 2 examples here just to kind of remind us how to do it. So I have 2/3 squared minus 1/2 times negative 1/6. So I do see lots of grouping symbols, but remember that this means if they have something to do on the inside of them, right? Something I can actually simplify. Here, my grouping symbols are just used to help clarify multiplication or a fraction. So there's nothing to do there. I do have an exponent though. So for my exponent piece, it's the whole thing in parentheses, squared. So I do the whole thing twice. And I get 2 times 2 is 4, and 3 times 3 is 9. I'm going to rewrite the rest of my example here. Next, I'm going to go ahead and do my multiplication, right? I have no more exponents, so next is multiplying and dividing, and I do see that right here. So I'm going to multiply straight across. 1 times negative 1 is negative 1. 2 times 6 is 12. So this becomes 4 over 9. Bring that minus sign down, minus, and then here I have negative 1. Now you don't need the parentheses there. I'm just using it to help clarify because I have a negative. And finally, I can do my subtraction. So subtraction changes to addition, and then my negative changes to a positive, right? We keep change. So here I have a little bit of work to do. I do have to get some common denominators here. So this one is going to be probably not too challenging. You can use your multiples list here. If I do my multiples list, I get 12, then 24, and then 36. And you'll see if you do 9, you get 9, and then 18, and then 27, and then you'll get 36 as well. So that 36 will match. So I have to change 4 9s to something over 36, and I have to change 1 12th to something over 36. So in the first case, I'm multiplying by 4, so I'm going to have 16. In the second case, I'm only multiplying by 3, so I have 3 here. Now I can go ahead and add. I get 19 over 36, and 19 is prime, and 36 is not divisible by 19, so I do know that I am done for this example. Okay, so again, we just really need to take our time because now we have order of operations, we have positives and negatives, we have fractions and whole numbers. So there's just more going on. But the basic rules are not changing. We're just now putting them all together, which can get tough. So I'm not saying it's easy, it's not, because we have a lot to keep in track of now in our brain. The other thing you can do too is as you go through each of these lectures, Maybe make yourself a little note card. I know I've mentioned before making note cards. So like for the sign rules, maybe make yourself a note card for the sign rules. Maybe make yourself a note card for fractions now. And then when we get to other sections, maybe make yourself a note card for decimals, just so you have a kind of like a little small reference sheet that you can refer to without having to go through all the videos again or all your notes again and constantly flipping back and forth. So that may be a good strategy as well as we get into more complicated material, just kind of synthesizing each chapter or each week's material, whatever works for you, into like one page or one note card, or doing it by topic. So that may help you as well. So then you have some quick reference sheets for yourself and you're not as bogged down by all the lectures. All right, I'm gonna do one last example here. So let's evaluate 2x plus y squared if x is equal to 3/4 and y equals -1/3. So I'm going to go ahead and evaluate. My x is 3/4, and again, this is multiplication here if there's no sign in between. And then for my y, I am squaring. So I do have parentheses here, but nothing to do inside them. I am following the order of operations. So I do want to do my exponents first. Now keep in mind that this is in parentheses, so that negative is also going to get multiplied through. So negative times a negative is a positive. This gives me positive 1/9. So my problem becomes 2 times 3/4 plus 1/9. I'm ready for my multiplication now. If I have a whole number, I am going to put it over 1. It just makes things so much easier to stay organized. I multiply across. 2 times 3 is 6, and 1 times 4 is 4. Now, you don't have to, but I do recommend simplifying as you go. It's just going to keep your numbers a little bit easier. So I can divide these both by 2 here to simplify that, and I get 3/2 plus 1/9. Now I do need common denominators. So the LCD here, and you can try this at home, is going to be 18. So I'm changing over 3/2 to something over 18 and 1/9 to something over 18. In the first case, we're multiplying by 9, so I end up with 27. So I have an improper fraction there, but that's okay. Here I have 2. So my problem becomes 27 over 18 plus 2 over 18. 27 plus 2 is 29 over 18. Now I'll let you guys try this at home, but it is actually simplified. So we could leave it like this. If you don't like it like that, though, you could always divide it and make it a mixed number. It goes into 29 only one time, and I have a remainder of 11. So I could also write this as 1 and 11 over 18. So just read those questions carefully, see how your final answer should be written. A lot of students make mistakes because they don't put it in the right final answer form. So you just want to see how the question is worded and if you need to, change over to a mixed number or leave it as an improper fraction. In either case, you should always check and make sure your final answer is simplified. The only exception would be is if the problem specifically said, do not simplify, but that's rare. So you want to also get in the habit of always checking those fractions and making sure that you are in lowest terms as well.